There are n number of samples distributed over p number of features, and we have to make use of your radial basis function based neural networks to classify them. The n samples were represented using a matrix x given by x1 1 x1 2 up to x1p, and x of p1, x of p2 up to x of uh, x of n1, x of n1, x of n2 up to x of np. So this is how your input samples were represented, and along with each sample there was its class was mentioned d1, d2 up to d of p. So their classes were also mentioned along with this. We tried to draw a neural network architecture based upon radial basis function for this, where your input layer was containing p number of features, x1, x2 up to x of p. Then comes your radial basis function layer, or you can say RBF layer. The RBF function to be used was Gaussian in nature, denoted by your Gaussian function, and this is your phi of 1, phi of 2, phi of 3 up to phi of n. So m number of neurons or m number of radial basis functions are to be used in your radial basis function layer or hidden layer, and their connections were like this. Each input layer neuron connected to each hidden layer neuron. At the hidden layer or RBF layer, the phi 1 of x was given by e raised to the power minus r square, or your x minus t1 square upon sigma square upon 2 sigma. So this was your formulation for RBF function number 1, same for 2, same for 3, same for 4, and so on till mth. For mth, it can be written as e raised to the power minus x minus t of m square upon 2 sigma of m square. It was sigma of 1 square. So every hidden layer, or you can say RBF layer neuron, will be generating this term as output. Now, just by looking at this neuron, there are two terms. One is this receptor T1 and one is this sigma 1. These are yet to be calculated. Now, how these terms are to be calculated, let us see. Suppose the initially your P patterns were to be clustered amongst your Z number of clusters, and initially in the intermediate way these P features were linearly or non-linearly mapped into M number of features given by your hidden layer. Let your input space was mentioned by or was represented using this way over P number of dimensions, and as we have to extend these P number of dimensions to M number of dimensions, try to point out P number of points in that space. 1, 2, 3, 4 up to M. So M points were designated in this space, and the step number 1, that is, try to assign a pattern X to the center which is closest to this. So assign this X to its nearmost center. That is this center number 1. Assign this x to this one, assign this to this one, and assign this pattern to cluster number 2, assign this pattern to cluster number 3, assign this pattern to cluster number 4, assign this cluster to pattern number n, and so on. Let there be 5 clusters. Let m is equal to 5 for now. So form 5 number of clusters: 1, 2, 3, 4, and 5. So initially 5 clusters were formed in the first phase. Find centroid. Let it be the centroid of all these. First cluster's centroid be this, second cluster's centroid be this, third cluster centroid be this, fourth cluster centroid be this, and fifth cluster centroid be this. Now again repeat the same process. Pick the sample and find its nearmost cluster, nearmost the centroid, and realign them to its nearmost. In the second phase, the alignment of samples will change. Means there will be some points lying here which will be going to this, and some lying here which will be going to this. So repeat this process till p or till your total number of samples. You will be finding that these clusters got changed. This cluster centroid got changed. So they will be changed. Earlier it was here, now shifted to here. Earlier it was here, now shifted to here. Earlier it was here, now shifted to here. Now repeat this till this process till fx number of times. Then you will be finding that your all input space is clustered amongst 4 number of groups. Now these 4 number of groups can be treated as your radial basis function space. Find, suppose, let this denotes centroid for the latest or the final centroid of this. This denotes for second, it is for third, this is the centroid for fourth. So these centroids at the final stage are going to act as a receptor. This point will act as receptor unit or T1 for this. This point will act as a receptor for this second neuron in hidden layer. Third one, it will going to act as the third receptor for this neuron. It will going to act as the mth receptor. So in this way we will be finding the receptor unit for all the radial basis functions. Now after finding the receptor, next thing